Uncovering the hidden factory of the shop floor requires detailed visibility of your manufacturing operations, more control of your processes, and insights into your performance. Siemens Opcenter provides this to increase your product quality and reduce the costs associated to inefficiency. So what is a manufacturing execution system? I have always seen MES as the solution that connects the usually disconnected area of the shop floor and its operators to all the other solutions that are typically used to manage your manufacturing operations and provide the operators with the information they need to complete their task. These include Teamcenter, the environment where engineering data is authored and controlled, such as your MBOM, bill of process, your electronic work instructions, tooling, etc. This information will then be fed directly to your operators at the point that they need it and in its latest version. Scheduling, a module of the Opcenter portfolio. This is where logistics staff will work to identify and escalate material shortages. They will plan, schedule, and optimize the sequence of work for the shop floor and then accurately forecast deliveries to your customers. The ERP is the financial backbone to your organization. This is where you will process your purchase orders, identify what you're making, order the material, and then provide this information to Opcenter to prioritize and execute accordingly. Lastly, operation technology. Able to connect and communicate with smart tooling and equipment on the shop floor and provide it with the set points and programs it needs. Opcenter then creates an enforcement layer to ensure the operator is producing and consuming the correct materials. They have the required skills and certification to complete their task, and they're using the correct equipment. Process documentation, work instructions, and data collection is being acknowledged and collated correctly. And as operations are being completed, you then have the root assurance that not only are operations being completed as they've been set out in the bill of process, but the scheduled sequence is being enforced onto the shop floor. And as they're being executed, this is updating the schedule, keeping your forecasts to your customers accurate and up to date. Non-conformances identified on the shop floor are being raised and escalated in Opcenter, which will notify the engineer, who will then be able to investigate the issue within Teamcenter, define a rework process, which will then be executed and controlled and monitored in Opcenter as if it were a normal operation. All the data collection that has been done as part of the operations and the non-conformances is being stored as a digital build record and is being fed back into Teamcenter as built. The ERP is being updated with the material consumption and the operation status to keep the financial records up to date. And you can monitor and report on your key KPIs such as OEE, or generate your own dashboards, or alternatively make that data available externally to be used elsewhere. What we're going to look at are 5 key capabilities of Opcenter and the value they bring to a manufacturing organization. These are advanced scheduling, operation execution, defect management, genealogy and reporting, and supplier collaboration. For advanced scheduling, we're going to spend a day in the life of a scheduler, and we're going to generate 3 separate schedules of different what-if scenarios, looking to optimize our resource utilization, minimize our late orders, and forecast deliveries to our customers. This is Opcenter APS. In the sequencer screen, you can see that I have a Gantt chart which has a horizontal timeline across the top. Just below are supply diamonds, which signal when material is becoming available for use from our suppliers. On the left-hand vertical axis, we have our resources, which are operating on a 3-shift pattern. Salmon is the night shift, green is the early shift, and purple is the late shift, and we have an off-shift period on Sunday. Below the Gantt chart, I have my secondary constraints, which typically represent anything that limits a resource's ability to sequence operation, and in this example, I have labor and tooling as my constraints. On the left-hand side next to the Gantt chart are our unscheduled operations, which there are 1,064. Each item is represented with an order number and an operation number. For the first schedule, I am going to activate animate sequencing so you can see how the operations are allocated to the Gantt chart when we generate our first schedule forwards by due date. The sequencer will then group and order each operation by their due date and allocate it to the Gantt chart where there is an availability in the resources shift pattern and the secondary constraint count that is associated to the operation. Now the scheduling has been complete, I'm going to turn off animate sequencing and then begin to investigate the schedule where I will highlight an order to see its end-to-end process. From when the material became available all the way through our manufacturing facility to its finish. By looking in the order details, I can see that it finished 2 days before its due date. We can then also view the Material Explorer, where we'll be able to see all of its material requirements, where they have come from and when they became available. Next, looking at the secondary constraints and where they're being used, I can click and drag on a secondary constraint and it will highlight each order where that's being used at that particular time. Looking at the unscheduled operations that were not allocated onto the Gantt chart, we can investigate these to understand why that is. And for this example, we can see that we have shortages in the Material Explorer, which can then be raised to our procurement team to escalate to the supplier. So we have seen how we can investigate the details of a schedule. Let's see how we can review the overall performance. Looking at the statistics, nearly 7% of our resource allocation is being spent performing setups. In the data, this equals to 20 days worth of time. Our on-time delivery performance shows that we only have 2 late orders, but I really want to try and optimize the schedule further by reducing that setup time, but by still keeping our late orders to a minimum. To generate our second schedule, first we need to unschedule the Gantt chart and then sequence the work using an out-of-the-box APS rule called Minimize Overall Setup. Here we're going to be asked for a look-ahead window, which is a forward planning time period the system will use to group the operation due dates together and sequence the workload to reduce the setup operations. The bigger the window, the more effective it will be in reducing our setup time. In the second schedule we just generated, as we look closer, we can identify that operations are being grouped together more efficiently with far less setup operations, which are represented as these black bars. Looking at the statistics, our setup has been reduced to 2%, which is less than 8 days spent on setup time. However, this has had a negative impact on our on-time delivery as we now have 21 late orders. Knowing this, we can generate a third schedule where we will aim to reduce that look-ahead window period and attempt to still maintain a low setup time but improve our on-time delivery to its previous levels. For the third schedule, this shows that we have maintained a low level of setup set at 3%, which is less than 10 days, and a 50% reduction from our original schedule. Our on-time delivery is still good with only 3 late orders, so now I feel like our sequence of work has been optimized. What I would like to do is investigate the late orders, highlight them to identify which resources are causing the bottlenecks, and then begin to understand if offering overtime on a Sunday morning will help us deliver this order on time and reduce our late orders back down to 2. As a scheduler, I was able to schedule our operations onto our resources and use our constraints. From the point the material came available, all the way through to where we were able to forecast deliveries to our customers, I ran through 3 separate scheduling scenarios, comparing the statistics, fine-tuning the sequence to improve our resource utilization while still delivering our products on time. This allowed me to optimize our resource selection, increase our efficiency, all in a matter of minutes in what used to take hours, or days.
For operation execution, we're going to look how an operator on the shop floor will complete their task. We're going to step through a production order and have our work instructions and documentation presented to us on how the process is to be executed. We're going to complete some data collection from smart tooling and validate that the correct material is being consumed. The operator landing page has been designed to work on mobile devices which are more ergonomic for the shop floor environment. So I, as an operator, can simply tap and start my operation. At this point, I'm going to be asked to select the serial number that I'm going to be working on and the piece of equipment I'd like to use. If in the event there was a preferred piece of equipment, this could be automatically highlighted or enforced on the operation. I can see the operation activities on the left-hand side of the screen. In the center, you can see that there's a highlighted activity, and on the right is any documentation associated to the operation. These can be images, drawings, models, videos, etc. In this operation, there are two sets of work instructions. The first work instruction is text-based and displays the safety instructions for the operation, which I must acknowledge, and then is time-stamped against the work order. The second work instruction is a data collection of the torque readings, which is acquired automatically from the smart tooling and when confirmed is again time-stamped. The second activity is a material consumption, where material is validated at the point of its usage. You will notice that there are two types of materials, serial number and batch ID. In this instance, I have set Opcenter to allocate the batch material automatically. However, serial numbers will need to be scanned and validated against the work order. If I scan an incorrect material, Opcenter will raise an error. If I then scan the correct material, it will assemble successfully. Data can also be collected on the tooling being used as part of the operation, such as its ID, its usage count and duration. This can be measured and tracked to the work order and monitored to the tool's life, meaning that maintenance and calibration can now be usage driven instead of interval based. On completion of the operation, supporting solutions will be updated, such as the schedule, keeping your forecast to your customers up to date, and your ERP, booking in your operational times. So as a production manager, I'm now more confident that my operators have the correct instructions to do their task and are more likely to follow them as they have acknowledged them at the point of the execution. Key data collection activities are being acquired and logged automatically, providing visibility and confidence in the completed process. And material and tooling are both being validated and tracked as part of the operation. Therefore, I have more control and visibility into my shop floor operations. Effectively managing defects on the shop floor is essential to your product quality and controlling the costs of non-conformances. We're going to jump onto the shop floor and step through an inspection operation where we will identify a defect, raise it up to manufacturing engineers, and then complete the rework operation. As a quality inspector, I start my operation and select the component that I am going to be inspecting first, in the event that there is more than one. As part of the operation, there are 4 separate activities to complete. A variable inspection, which is asking me to take a gap measurement on the gimbal. If the measurement I then enter falls out of tolerance, I would then be able to categorize the failure, which will be useful when it comes to understanding long-term trends. In this instance, we're going to be within tolerance. There is an attribute inspection, which is asking me to check a feature on the component, and in this case, I'm performing a power on end test. If I define the test as failed, Opcenter again will prompt me to enter a failure category. However, again, this test has passed successfully. The third activity is a visual inspection, which has presented me with a grid-marked visual aspect of the component that has been defined in Teamcenter. And after finding the defect on the component, I will then select the most appropriate failure category and mark the aspect with the indication of where the defect was found. When I raise the non-conformance, I will then be able to add in additional information to help the engineer make an informed decision on how to proceed. This can include text, images, or documentation. I am also going to link the component serial number to the non-conformance, and that will allow us to have full traceability before I save it and send it to my engineers. As a manufacturing engineer, I will now receive a notification, both via email and in the system, that a defect has been raised and it needs my attention. I will be able to review the defect within the non-conformance tab to review all the details provided by the operator, such as when it was raised, the operator who raised it, the work order, component details, and the operation. The associated failure category is also presented. I will be able to see the full history of the notification and any changes that were made with any documentation or notes provided. On review of this non-conformance, I am aware of this as an ongoing issue that has a predefined rework process. So I'm going to change the status of the non-conformance to rework and select associated rework code, which will send it back to the shop floor for rework execution. Returning to the operator landing page, I'm easily able to find the associated rework order by the naming convention setup. So I can simply select and start it as if it was a normal order. In this operation, I have a set of work instructions which cover the health and safety and how to proceed to disassemble and reassemble the gimbal to correct the alignment issue that was found. There is a data collection requirement for the new torque readings as part of the bolts being retightened, and a confirmation from the operator that the alignment issue has been corrected as part of the rework operation. Before we complete the operation, because we are tightening bolts, we are also going to collect data of the tooling that has been used. Now that the rework operation has been completed, the component has been returned to its original work order to be continued, and you will notice that the operation has been placed on pause for the duration of the rework. The previous visual inspection with the defect is still present as part of the operation. So we will request to use a new sample and confirm that no new defects were found. The genealogy of the order will hold both visual inspections details. For the final buy-off, we require the approval of our supervisor, where they will be required to confirm that they accept the work that has been done and sign it off using their credentials. Now that there is direct communication and improved collaboration between your shop floor and engineering, defects are going to be identified and then solved more effectively and in a timely manner. Rework operations are being executed within Opcenter, meaning that you have full traceability of the work that has been done. Costs associated to your non-conformance will be reduced as the life cycle management of them is improved. We have seen how Opcenter is monitoring, providing controls and data collection for our shop floor operations. Now let's see how it will provide our manufacturers with the end-to-end visibility needed to provide a complete traceability of our products. How it will help us meet strict regulation compliance that's relevant to our industry by having reliable and comprehensive data at our fingertips. And how it will monitor the performance and output of our assets. Every interaction that we as an operator have had with the production order has been recorded and stored in the genealogy of the component, including the rework of the defect we found as part of the inspection. We can then drill down into the rework order, select the operation, and see each interaction taken as part of that process, such as the tooling usage, the torque readings, along with the others. If we look at its original production order and open Op20, we can see the details of the non-conformance, its associated defect, the gap inspection value, the attribute inspection confirmation, and the total number of visual defects that were identified both on the first and second inspection after the rework was completed. In Op10 of the production order, we will be able to see the material consumed, including the serial numbers and the work instruction acknowledgement from the operators. All of this information provides detailed traceability and visibility of our products and valuable process documentation for auditors. For performance monitoring, Opcenter Intelligence provides the flexibility to generate dashboards to suit the user.
For example, here we have a configured report that provides the operator with clear indications of their performance, tracking their OEE, their output, their quality, their availability, and a count of the good and scrap units. When there is a change in the status of the machine, the report clearly shows this and will provide the operator with the ability to provide a justification. This same report can then be scaled to a team leader who will want that same visibility of multiple resources at the same time. Dashboards are easily configured and can be done so quickly by simply clicking the resource you're interested in and the KPIs or variables you want to monitor. Historical data can also be reported on simply by adjusting the start and end time of the dashboard. All of this can continually be scaled to suit the audience and provide analytical dashboards monitoring trends across multiple sites that will enable more informed decision making from senior leaders who can drill down into these trends and focus on the important details of their operations, creating more focused initiatives for improvements. With that end-to-end visibility and traceability of our products, we can provide our customers with more confidence. We have the reliable data and documentation of our processes to meet our regulation standards and compliance. And monitoring performance will allow us to make better decisions on how and where we need to improve. So it's clear how Opcenter can bring value and improve the operations of our manufacturing environment. But what about our suppliers? Manufacturers are heavily reliant on the performance of their suppliers, and it's very common for components to be lost or damaged as part of that transaction. We are going to see how we can improve visibility into the operations of your suppliers and have full traceability of the components the supplier has and interactions with those components, and then be supplied with the quality assurance of the components digitally before they are returned to site. The Opcenter Supplier Collaboration app provides the suppliers with the manufacturing execution capabilities of Opcenter without the need for them to have the software itself. As production orders and/or operations can be transferred to an external application to be executed offline, these can be then sent to the supplier either via device or via a file transfer. Therefore, the supplier will have all the necessary information they need to complete their operation, but nothing you don't wish for them to share. As the supplier then completes the operation, data can be logged and collected as set out in the work instructions, meaning you will have full visibility of their process and traceability of it against the component's serial number. They will also be able to attach the certificate of conformance to the production order at their site, therefore reducing paperwork when handling the goods receipt. Any defects found and non-conformances raised by the supplier will be done so within the solution, giving you full visibility of the details as we have previously seen in the defect management section. On completion of the work, the supplier can then transfer the files back to your site, where you can then download them and view all the details, such as the non-conformance, process documentation, and the certificate of conformance, before you make a decision on whether you want that sent back to your site. So therefore, if there are any discrepancies, these can be amended before the transfer of goods happens, avoiding any unnecessary transportation costs and lost time. Within the work orders genealogy, you will be able to see the full visibility of the supplier's interactions, same as previously shown in the genealogy and reporting section. Seamless transfer of process documentation, full visibility into your component's external operations, and reassured quality controls and measures will enhance your collaboration with your suppliers and increase the value of your relationship to each other. Siemens Opcenter is focused on helping manufacturers of all industries to improve the quality of their shop floor operations by breaking down the silos between your operators and your engineers. Our solution is designed to integrate with PLM and ERP solutions in an aim to standardize the way people work, avoiding redundant data and providing a single source of truth
It's then built with the flexibility to run on mobile devices so that the shop floor environment can embrace digitalization with convenience.